Hi friends, today we discussing about what is resistors, types of resistors and color coding. First of all, we need to know what is electronic components. Electronic components are the fundamental discrete devices that make up electronic circuits. Simply, electronic components are the elements of the circuit which help in its functioning the electrical circuit. In other terms, electronic components are the parts used in devices that construct electronic circuits. Electronic components are the basic building blocks of an electronic circuit, any electronic system or any electronic device. They can control the flow of electrons in an electronic system or electronic circuit. Electronic components are very small, so that they are easy to carry them from one place to another place. The cost of electronic components is also low. Electronic components consist of two or more terminals. An electric circuit contains many small and large components. Electronic components are classified into two major classes. First one, passive components. Second one, active. Passive components are electronic devices that don't need an external power source to operate actively. They mainly resist, store, or control the flow of electric current or voltage in a circuit without actively amplifying or generating signals. These passive components belongs to inactive functions of components. These passive components do not have capacity to amplify the voltage or to rectify the supply. Without these components, assembly of electronic circuit is not possible. Resistors, capacitors, inductors are called as passive components. Other passive components include transformers, diodes, thermistors, varactors, transducers, and many other common components. These components are available as through whole and components, and many are available in common packages with standard LAN patterns. Active components are electronic devices that need an external power source to work. They actively control and manipulate the flow of electric current in a circuit. These components can amplify, switch, or generate electrical signals. These components are capable of performing active functions like amplification, rectification and switching. They are called as active components. They are classified into two groups. The different types of active components include diode, transistor, integrated circuit are called as active components. Electron tubes like vacuum tubes like diodes, triode. Semiconductor devices like diodes, LED, operational amplifiers, logic gates, tunnel diode and Zener diode, etc.
Next, we will discuss about what is resistor. Explain the different types. The definition of resistor. The resistor is a passive electrical component that creates resistance in the flow of electric current. In almost all electrical networks and electronic circuits they can be found. The resistance is measured in ohms. An ohm is the resistance that occurs when a current of 1 ampere means A passes through a resistor with a 1 volt means V drop across its terminals. The current is proportional to the voltage across the terminal ends. This ratio is represented by Ohm's law. R is equals to V by I. Resistors are used for many purposes. A few examples include limiting electric current, voltage division, heat generation, matching and loading circuits, gain control, and setting time constants. They are commercially available with resistance values over a range of more than 9 orders of magnitude. They can be used as electric brakes to dissipate kinetic energy from trains, or be smaller than a square millimeter for electronics. High-power resistors that can be used as motor controls and power distribution systems. The right side images shows the symbol of resistor and image of resistor. In the resistor the color bands indicates first band, second band, third band, multiplier and tolerance. What is bands, multiplier and tolerance? These concepts we will discuss about in the section of color coding. Next, types of resistor. There are numerous types of resistors used in electronic circuits. These different types of resistors have different properties depending upon their manufacture and construction. There are different types of resistors available for various applications. The resistors are available in different shapes, size, and materials. Resistors are classified into 2 major types, that is, first one linear resistors, second one nonlinear resistors. Let us see the classification of resistors. Resistors can be broadly classified into 2 types. First one linear resistors, and second one non-linear resistors. Linear resistors divided into 2 types. First one fixed resistors, second one variable resistors. Fixed resistors have a constant resistance value, while variable resistors allow for adjustment of the resistance. Fixed resistors are electrical components with a specific, unchangeable resistance value. They restrict current flow in circuits and are used for various applications like voltage division, signal level adjustment, and current sensing. Within each category, there are several types, each with specific characteristics and applications. 3 major types of fixed resistors are: first one wire wound resistors, second one thin film resistors, third one carbon composition resistors. Variable resistors are electronic components that allow for the adjustment of resistance in a circuit. They are used to control the flow of current in a circuit by changing the amount of resistance offered to the current. The common types of variable resistors are potentiometer and rheostat. Nonlinear resistors are those types of resistors where the electric current flowing through it changes with the exchange in applied voltage or temperature and does not change according to Ohm's law. There are several types of nonlinear resistors are thermistors, varistor resistors, photoresistor or LDR. LDR means light-dependent resistors. Surface mount resistors. Next, we will discuss about linear resistors. The resistors whose value changes with the applied temperature and voltage are called linear resistors. It means a linear resistor is one whose resistance doesn't vary with the flow of current through it. Simply, a linear resistor is defined as a 2-terminal circuit element which satisfies Ohm's law. We know the Ohm's law, expressed as V, is equals to I, R, defines the relationship between voltage, current, and resistance in an electrical circuit. That is, the voltage across the resistor is proportional to the current flowing through it. Linear resistors divided into 2 types. First one fixed resistors and second one variable resistors. Next, fixed resistors. Fixed resistors are resistors with a specific value. It means fixed resistors are electrical components with a specific, unchangeable resistance value. Simply, Fixed resistors are the resistors whose resistance does not change with the change in voltage or temperature. Next we learn types of fixed resistors. Fixed resistors are also further classified into different types based on the manufacturing process and the material used. First one, wire wound resistor. Second one, thin film resistors. Third one, carbon composition resistor. Now, let's know about the wire wound resistors. A resistor that is designed using a conductive wire to limit or restrict the flow of current within a circuit. It means wire-wound resistors are passive electronic components that restrict current flow in a circuit by using a metallic wire wound around a non-conductive core. They're known for their ability to handle high power and provide precise resistance values, making them suitable for various applications. Wire-wound resistors are designed by winding a conductive wire, typically made of alloys like nichrome or manganese, around a non-conductive core. The resistance value is determined by the wire's length, diameter, and material, with longer, thinner wires providing higher resistance. The wound wire is often coated with an insulating material like vitreous enamel for stability, especially at higher temperatures. These resistors are used in industrial and high-power applications like fuses, circuit breakers, such as power supplies, motor drives, and testing equipment, due to their ability to handle large amounts of power and maintain precision. This image shown wire wound resistor. A wire wound resistor is a type of resistor made by winding a resistive wire around a non-conductive core, often made of ceramic, plastic, or fiberglass. It is used to limit or control the flow of electrical current in a circuit. Next, we know the advantages of wire wound resistor. First advantage, this resistor is employed in high-power circuits. It means wire-wound resistors are designed to handle significantly higher power levels than many other resistor types, making them ideal for applications where substantial heat dissipation is required. Second advantage, it will not affect by the noise. It means, the solid, single-piece wire construction of wire-wound resistors results in inherently low noise levels, which is crucial in sensitive applications like audio circuits and precision measurements. Third advantage, it is thermally constant. It means, they exhibit good thermal stability, meaning their resistance value changes minimally with temperature variations, ensuring predictable performance in various environmental conditions. Next, we know the disadvantages of wire wound resistors. First disadvantage. These resistors are used for only low frequencies because it works as an inductor at high frequencies. It means the winding of the resistor creates a coil-like structure, which behaves like an inductor at high frequencies. This inductive effect can distort signals and affect circuit performance, making them unsuitable for applications requiring high-frequency operation. Second disadvantage. It is expensive as compared with carbon resistor. It means, wire-wound resistors are often more expensive and larger compared to other resistor types. This makes them less cost-effective and less space-efficient in designs where these factors are important. Third disadvantage. It is larger in size. It means, a significant disadvantage of wire wound resistors is their large size, which can be a limiting factor in applications where space is constrained. This size is due to the physical nature of the resistor, which involves winding resistive wire around a core. Next, Applications of wire wound resistor. First one, space and defense. It means, wire wound resistors are used in spacecraft power systems, onboard electronics, and instrumentation. They are found in military vehicles, radar systems, and communication equipment, where reliability and precision are paramount. In simply, used in military and aerospace electronics for high precision and stability in extreme conditions. Second one, transducer devices. It means wire wound resistors act as precise elements in devices converting physical quantities like pressure or force into electrical signals. Third one, medical devices. It means, wire wound resistors are employed in sensitive equipment like ECGs or defibrillators due to their accuracy and reliability. Fourth one, computers. It means, wire wound resistors serve in power supplies and control circuits where stable resistance is crucial. Fifth one, telecommunication. It means, wire wound resistors are used for signal processing and voltage regulation in communication hardware. Sixth one, current sensing. It means, function as shunt resistors to measure current by detecting voltage drops. Seventh one, telephone switching system. It means, wire wound resistors provide consistent resistance for signal routing and circuit protection. Resistors are the most fundamental electrical and electronic components which are widely used in all electrical circuits. Generally, resistors restrict the current flow within a circuit to implement resistance. The products based on film technology have developed adequately to change older carbon resistors. These are classified into two types: thick film and thin film or metal film. These two film type resistors are the most creative kinds of resistors used in various electronic devices. These types of resistors look small and smarter but are designed differently with different properties. Let's learn about thin film resistors. The resistor which uses a thin film resistive layer is known as the thin film resistor. This layer is arranged on top of a ceramic base. As compared to the thick film resistor, the thickness of this resistor is very thin, approximately 0.1 microns. Thin film resistors are generally preferred in high-precision applications due to their inherent stability, accuracy, and better temperature coefficient. This is primarily because the thin film process, which involves depositing a very thin layer of resistive material onto a substrate, allows for precise control over resistance values and material composition, leading to more predictable and stable performance. The image shown the construction of the thin film resistor. The construction of the film resistor can be done through a sputtering process of the resistive material over the ceramic. After that, the surface can be etched through ultraviolet exposure and required etching techniques. This resistor uses different materials. While making like bismuth ruthan, tantalum nitride, lead oxide, nickel chromium and ruthenium oxide. After that, the etched film can be trimmed with lasers. The width of the film decides the resistance, however this can be adjusted through laser trimming if necessary. On the other hand, the film can be sputtered on a cylindrical face through axial leads, so the resulting components are normally known as metal film resistors instead of thin film, but the concept is similar although at the cost of parasitic inductance. Next, the advantages of thin film resistors. First advantage of thin film resistor: high electrical performance. It means, offers precision and stability over time. Second advantage of thin film resistor. High frequency response. It means, suitable for high-speed and radio frequency circuits. Third advantage of thin film resistor. High power rating. It means, can handle higher loads in compact sizes. Fourth advantage of thin film resistor. Low noise. It means, generates minimal electrical noise, ideal for sensitive applications. Next, disadvantages of thin film resistors. First disadvantage of thin film resistor. Delicate construction. It means, thin layers can be easily damaged. Second disadvantage of thin film resistor. Higher cost. It means, more expensive than thick film or standard resistors. Third disadvantage of thin film resistor. Careful handling required. It means, sensitive to physical and environmental stress. Next, applications of thin film resistors. First one, medical devices. It means thin film resistors, used in diagnostic and monitoring equipment. Second one, aerospace and defense. It means thin film resistors preferred for reliability in extreme conditions. Third one, telecommunications. It means thin film resistors ensures precision in signal processing. Fourth one, instrumentation and test equipment. It means thin film resistors delivers accurate measurements. Fifth one, automotive electronics. It means thin film resistors supports advanced driver assistance systems. Sixth one, consumer electronics. It means thin film resistors found in devices like smartphones and laptops. Seventh one, industrial control systems. It means thin film resistors used for precise control and automation. Next, we discuss about the carbon composition resistors. Carbon composition resistor is one of the fixed resistor. Another name of carbon composition resistors is carbon composite resistors. Carbon composition resistor is an old type of resistor but used as a main resistor in many tubes or valve-based devices such as radios, TVs, electronic devices. Carbon composition resistors is used to restrict or reduce the flow of current to a certain stage. We will see the construction of carbon composition resistors. The carbon composition resistors are made from a solid cylindrical resistive element with embedded wire leads or metal end caps. The cylindrical resistive element of the carbon composition resistor is made from the mixture of carbon or graphite powder and ceramic means made of clay. Carbon composition resistors are made out of fine carbon particles mixed with clay. It becomes solid form after baking. Carbon composition resistors are widely used in electrical and electronic circuits. The carbon powder acts as the good conductor of electric current. A fixed value resistor with a carbon composition can be used to restrict or regulate the passage of electric current. It has a solid cylindrical resistive element with integrated wire leads or metal end caps to which the lead wires are joined. It is made of carbon powder and graphite. Its resistance value is determined by the ratio of carbon to binder material. The more carbon in the mixture, the lower the resistance value, and vice versa. The solid cylindrical resistive element is covered with plastic to protect the resistor from outside heat. It is ideal for high frequency. Very cheap to make available within 1 ohm to 25 megaohms. A carbon composition resistor is made by combining carbon granules with a non-conductive ceramic substance and molding it into a cylindrical shape. To provide electrical connections, two metal leads are affixed to the ends of the cylinder. The ceramic layer offers mechanical support and insulation, while the carbon composition material works as a resistive element. The process of manufacturing of carbon composition resistor is. The raw material for the carbon composition resistor is a blend of graphite, ceramic dust, and resin. The mixture of the above said materials is pressed under high temperature and pressure to form it into sticks. Two metal caps are fitted at both ends of the stick-shaped resistor. The assembly is then heated up, and after this process of baking a massive resistance body is created. Then, the coating is done on the resistor to make the resistor body non-porous. The resistor body is cut into the lengths for the required resistance value. For different power rating resistors, the diameter is varied to vary the heat dissipation. Next, amount of carbon added. The resistance of a carbon composition resistor is determined by the amount of carbon mixed with a binder material. Increasing the amount of carbon in the mixture generally leads to a lower resistance value. Less carbon in the mixture results in a higher resistance. Carbon is a good conductor of electricity, meaning it allows current to flow relatively easily. A binder material, like a plastic resin or clay, is mixed with the carbon powder to hold it together and allow for molding into the desired shape. By adjusting the ratio of carbon to binder, the overall resistance of the resistor can be controlled. More carbon in the mixture means more pathways for current to flow, resulting in a lower resistance. Less carbon in the mixture means more resistance to the flow of current, resulting in a higher resistance. Thus, the carbon composition resistor with more carbon has low resistance. If less amount of carbon is added, only a small amount of electric current flows and more amount of electric current is blocked. Thus, the carbon composition resistor with less carbon has more resistance. In simple terms, more carbon has low resistance. Means more amount of electric current flows. Less carbon has more resistance. Small amount of electric current flows. Next, we discuss about the advantages of carbon composition resistors. First advantage: high energy pulses. It means they can endure high energy pulses without damage. Second advantage: low cost. It means relatively inexpensive to manufacture and purchase. Third advantage: compact size. It means available in small sizes, making them suitable for space-constrained designs. Next, disadvantages of carbon composition resistor. First one, the stability of the carbon composition resistor is poor. It means the resistance value of carbon composition resistors can change over time and with environmental conditions, making them unsuitable for applications requiring precise resistance. Second one, generates huge noise. The resistive element's non-uniform composition and granular structure can lead to significant noise generation, which can interfere with sensitive circuits. Third one, accuracy is less. Carbon composition resistors typically have a tolerance of 5% or higher, meaning the actual resistance value can deviate significantly from the marked value. Fourth one, it absorbs the water, so it can lead to an increase or decrease in the resistance. It means, carbon composition resistors are made from a mixture of carbon particles and a binder, which can be porous and susceptible to absorbing moisture from the surrounding environment. Next, applications of carbon composition resistors. First one, circuit protection. It means, carbon composition resistors used in surge protection due to their high energy handling capability. Second one, high voltage power supplies. It means, carbon composition resistors used in suitable for circuits that require withstanding voltage spikes. Third one, current limiting. It means, carbon composition resistors used to restrict current flow in sensitive components. Fourth one, high power or strobe lighting. It means, carbon composition resistors used in handles pulse currents effectively in lighting systems. Fifth one, welding equipment. It means, carbon composition resistors used in durable enough to manage high power fluctuations. Sixth one, medical defibrillators. It means, carbon composition resistors can absorb large, short-duration energy pulses reliably. Seventh one, general-purpose electronics. It means, carbon composition resistors employed in non-critical applications. Eighth one, test equipment. It means, carbon composition resistors used where ruggedness and pulse durability are required. Ninth one, computers. It means, carbon composition resistors found in older systems where pulse tolerance was critical.